So in this video of chapter 1 number systems, we are going to see an interesting thing to do. We have an interesting task to do, and that is locate root 2 on the number line. So in the previous video we saw that a number line has all the rational numbers and all the irrational numbers, and we know that root 2 is an irrational number. So let us see how we can plot an irrational number on a number line. So first of all, let's draw a number line. So this is our number line. Okay, so I'm going to start plotting the numbers. Let's say this is -2, then this is -1, then this is 0, then this is 1, then this is 2, this is 3, okay, and so on. Now we know that this, now let's focus on this part. I'm going to use a highlighter. Okay, let's focus on this and this. Okay, we know that this is of length 1. Okay, I'm in fact going to note it down. This 0 to 1 is of length 1. Now there's a construction that I'm going to make, and the construction is we're going to draw a line perpendicular, okay, perpendicular to this point, and that will be of length 1. Okay, in fact, let's give names to these points. Let this point be A, let this point be B. So let us draw a line perpendicular from this point B, okay, perpendicular to this point B, which is of length 1. So it's going to be something like this. Okay, and this is of length 1. That is very important point. Let's say this point is equal to C. Okay, now let us connect this point A and this point C. Okay, so that's what I'm going to do. Let us connect this point to this point. Okay, now let's get rid of this highlighted thing. Okay, so okay, now let's zoom in a bit. Yes, so this is our triangle ABC. Okay, in ABC, AB is of length 1 and BC is also of length 1. So what will be the length of OC? Okay, now the key thing is that this is a 90-degree triangle, which means it's a right angle triangle. So if it's a right angle triangle, we can use the Pythagoras theorem. What is the Pythagoras theorem? So I'm just going to write it down here. So in right angled triangle ABC, okay, we have AC square, which is the hypotenuse, that is equal to AB square plus BC square. Okay, why is this? Because this is the Pythagoras theorem. So Pythagoras theorem. Okay, so that is equal to, what is AB? AB is 1 and BC is also 1. So I'm just going to substitute 1 square plus 1 square. That is going to be equal to 2. Therefore, AC square is equal to 2, and therefore AC is equal to square root of 2. So the length of AC is square root of 2. So let's come here. Now let's make a note of that point. The length of AC is this length is square root of 2. Okay, so we have got a line AC which is of length square root of 2. Now all I have to do is to plot this line AC on this number line. Okay, so what I'm going to do is I'm going to take my compass and keep the center here at the point O. So let's use highlighter. I'm going to put my center here at point O, and then I'm going to construct and I'm going to extend this line OC to the number line. Okay, so as a in order to understand this concept, let's come here and I'm going to draw a circle now. Okay, so consider this circle. This is the center of the circle. Okay, now consider this is the radius of the circle. Okay, let me use a straight line. Now consider this is the radius of the circle. Now if I keep a compass with the center at this point, and if I move this radius down, okay, the length of the radius does not change. So even at this point, the length of the radius is same. So imagine the length of this radius was square root of 2, and let's say this was our A and this was our C. Now if I draw a circle with A as a center and this C as the endpoint, so no matter where it goes, the length of this AC radius will always be root 2. Okay, so this is also root 2. Let's say this point is our point B. So this is the exact same thing happening here. Okay, this is our A, this is our A, this is our C with the length root 2, this is C with the length root 2. All I'm going to do is draw a circle, and that circle will touch somewhere here. Okay, so this B is incorrect. Let's not use B here, that might be confusing. Okay, so now okay, so let's come here. Now, so imagine now I am putting a compass here and drawing a circle with this, and it will come down, 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 and it will cut this number line at some point. Okay, and very obviously, whatever is the length of OC will be the length of this. Okay, let's name this point as P. So let this point be P. Okay, now note. So I'm just going to write here note OC. Oh, sorry, I'm saying OC, but actually that is 0. This is AC. Okay, AC is equal to AP, which is equal to under root of 2. Okay, same. This concept of circle. This AC, no matter where you go, it will be of the same length root 2. So this AC, I have got it down on the number line. So this highlighted thing, let me highlight this thing and this thing, they will be of equal length. So AP, the length of AP will be equal to root 2, which means this point, if you zoom in, this is the point on the number line which is of the length root 2, and thus we have very successfully and very accurately located root 2 on the number line. So this is how you locate root 2 on a number line. Now in a very similar fashion, we can locate root 3 on the number line. So let's see how that can be done. So once again, very quickly, I'm going to take a number line. So this is a number line. These are its two ends. Okay, I'm just going to focus on the positive parts. So let's say this is 0, and this is 1, and this is 2, and this is 3. Okay, so first of all, I'm going to represent whatever we had represented here. Okay, the way we got root 2 is the exact way we are going to do here. Okay, so this is of length 1. Okay, I'm going to construct a perpendicular of same length 1. Okay, and then I'm going to connect this to this. Okay, so let me write it down. This is also of length 1, this is of length 1, so this is of length root 2. Let us give the numbers, let us give the names to these points. So this point is A, let this point be B, let this point be C. Okay, so we know this is the same thing what we had done before. This is our 90-degree rectangle ABC. Now I'm going to do further one more step, one more construction. Now focus on this line AC. Okay, now from this point C, I'm going to draw a perpendicular of length 1. Okay, perpendicular to this line AC. So let's use a different color. Okay, so from this line, from this point C, I'm going to draw a perpendicular of, I'm going to draw a perpendicular of length 1. Okay, so once again, that length is very important. So this length is going to be equal to 1. So I'm going to just mark here 1. Okay, and now I'm going to connect this point A to this point. Let's call this point as D. So I'm just going to make a D, and let's connect them. Let's connect A to D. So do. Okay. Note this is 90 degree. So this is 90 degree. Okay. So once again, let's okay. So let's give D. Now once again, if you focus on this triangle, so let me use a highlighter here. If you focus on this triangle ACD, okay, ACD is a right angle triangle. Yes. So I'm just going to write it down. Where is my black? Yes. So triangle ACD is right angle triangle. Right angled triangle. Okay. Therefore, AD square. So I'm going to get AD square is equal to AC square plus CD square. Okay. Why is this? Because it's a Pythagoras this is the Pythagoras theorem, and important point, AD is our hypotenuse. Hypotenuse is the side which is opposite to the 90 degree. Okay, now we know the length of AC, which is root 2. We know the length of CD, which is 1. We are just going to substitute here. So that is equal to root 2 the whole square plus 1 the whole square. Okay, and that is equal to 2 plus 1. Okay, and that is equal to 3. So therefore AD square is equal to 3. Okay, so I'm going to continue here. Therefore AD is equal to square root of 3. Okay, now this is important. The length of AD is going to be square root of 3. So this is my AD, this is A and this is D. So the length is going to be square root of 3, and I'm going to make a note of it. This is going to be square root of 3. Let's remove the highlighted part so that it's less confusing. Yes. So once again, quickly to revise, we already had this AC, which is of length root 2. Now from this point C, I constructed a 90 degree perpendicular, okay, of length 1. So we got CD of length 1, then we connected AD. Now this is root 2, this is 1. So by Pythagoras theorem, AD is equal to root 3. Okay, so once again, we are going to do the same next step what we did here. Okay, we are going to just extend this to the number line using a compass. So once again, you have to imagine this circle. Okay, and if this is of length root 2, in this case it's root 3, then if you extend it down and construct a circle, it will always intersect the number line also with the same length. So let's come down here. Now this thing we can move so that yes, let's move it here. These were the calculations. Okay, now this AD being the radius of our circle, assume a circle with AD as a radius and A as the center. I am going to extend, okay, this line downwards. So this will like this. I'm going to draw a circle and it will come down, 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 down. So it's not done very nicely, but it will come and intersect this number line at a certain point. Let's call that point as P. Okay, now note that AD is equal to AP. That is very important. AD is equal to AP, but what is AD? It is equal to root 3. Thus we get AP. So I'm going to use the highlighter. We get this AP, this length AP of length root 3, and thus P becomes our point root 3. Yeah, let's remove the highlighter. It's not. Let's use a different highlighter. So this thing AP. So AP is of length square root of 3. So thus we have very successfully plotted square root of 3 on this number line. It will be a bit closer to 2 because the value of square root of 3 is 1.7. Whereas here if you see here square root of 2 will be closer to 1 because this value is 1.4. Okay. So this is how we locate irrational numbers on the number line. The point is that each and every rational number and each and every irrational number is present on the number line, and all we have to do is find out a method to plot them on the number line.